Good day, guys. It's Dylan here, and today we have another config series video. And today we're going to do site-to-site VPN. So, site-to-site VPN is one of those VPN options to create a secure transmission of data. That would include like your plain data, voice, video between two branch sites. I did say one of the options because there's so many options out there to create a VPN. You have your DM VPN. You can do like MPLS network. This site-to-site VPN, it does have its own flavor. In this video, I'm going to show you crypto maps. Then there's also that option of using GRE tunnels. There's a VTI version, and yeah. This is done over public internet. Advantage of this solution is it provides a cheap alternative rather than paying. There are expensive solutions out there and more complicated solutions like doing a DMVPN. It's cheaper in a sense that you're doing this over your public internet, which is way cheaper than getting a provider do an MPLS network for you. The disadvantage of this one would be, well, it's not flexible in terms of management. Think of it as N+1. So from the name itself, it's site-to-site VPN. So in the event that you need to start adding sites, that would mean each site would have its own tunnel between each endpoint. Just like in our diagram here, you have Brisbane, Gold Coast. Let's say you start adding another site like Melbourne. So if I can draw that out here, so let's say you add another site here, and we'll call that the site is in Melbourne, and you connect that to the internet. So site-to-site VPN, like I said, it creates a private tunnel between the two endpoints, or in PCs on the LAN side, it's gonna go through the tunnel, then out the other tunnel to reach its destination. Right? Yes, it will use the internet as the underlay, but because of that tunnel, it's gonna use the tunnel. It's gonna keep itself from being natted to reach the other destination. Now going back, so in the event that you start adding sites, like just in our diagram here, it gets challenging to manage because you're gonna start creating tunnel for each site like that. Okay, so you have tunnel 1 here, then tunnel 2, tunnel 3. So what if you start getting more sites like site 4, site 5, and so on? Okay, each one would have its own tunnel per site. Okay, now what would be the requirements, or what would be the prep work that you need to do before you can even start configuring site-to-site VPN? One is you need to make sure you have the license on your Cisco device, so you can actually perform site-to-site VPN or any kind of VPN. Two, this is particularly important if you're only managing one half of the device and you're working with another IT company who manages the other site. So you need to know the WAN IPs and obviously your own router that you're managing. Perfect if you're managing both routers. You need to figure out like what's the WAN IP of the other router. Ideally, for simplicity's sake, for the purpose of this demonstration, that WAN IP should be publicly routable. The next, you need to agree on the phase 1 and phase 2 of your VPN, and I'm gonna get into that later. So this would include the encryption, the hashing algorithm, the pre-shared key, and the Diffie-Hellman group. The next is you need to know the LAN subnets that will be talking to each other. So again, this will apply if you are only managing one half of the network. You need to know, like, you need to talk to the guy who's responsible to the other network, like, hey, what's your LAN range? So we know that what we're gonna allow in our ACL or in our access list. Okay, so now let's begin. So let me show you my super PuTTY right here. So in this scenario, we'll assume that we have control over both devices. We have control over the Brisbane and the Gold Coast router. So let's go here to and the PC right here. We'll pretend like I've converted the router as, we'll pretend that's the PC. So on the PC in Brisbane, if I ping Google 8.8.8, so we simulate that we can actually reach that. If I do show IP interface brief, so I'm getting my IP via DHCP, and obviously I can ping my default gateway on the LAN, which is 10.200.1.1. And now let's go to the router. I do show IP interface brief. Okay, so what my WAN IP is 10.149.80.1. Let me paste that somewhere in my notepad. Okay, then we are creating a site-to-site VPN. As I mentioned, one of the requirements is we need to know the WAN IP. So now let's go to the Gold Coast router, which if we look at our diagram, it's running at 10.200.2.1. Let's check first my PC in the Gold Coast. Yes, it's reaching the internet. Ping my default gateway LAN. I know you might be saying, Dylan, that's silly. The mere fact that you were able to reach Google, it means you don't need to ping your LAN default gateway. I mean, that's fine. Okay, so now let's go to the router. Let's figure out what's your WAN IP. And your WAN IP is 103.40.40.2. Okay, so now we know the WAN IP, we know the LAN range. Same also goes for Brisbane router. We know the WAN IP, we know the LAN range. Okay, now let's go to phase 1 and 2. Okay, in order for us to do that. Oh, by the way, just to show you that I have netting in place, if I ping the LAN subnet on the other end on the 2 network, that's going to be unreachable. Okay. Alright. Now let's configure site-to-site VPN. So let's do phase 1. Crypto ISACAM policy 10. We'll start with encryption. Oh, you know what? Let me give you a tip, and I learned this when I was doing my CCNA security. Think of the word haggle. So before any two routers can communicate with each other, they need to haggle on the phase 1 and phase 2. So what is haggle? So haggle is let's write it down here. Haggle. Okay, H stands for hash, A stands for authentication, G starts for means group, or the Diffie-Hellman group. L is for lifetime. We are going to use the default. Then CE is for encryption. Okay. So now let's use haggle. So for haggle, for H, we're going to use MD5. For authentication, we're going to use pre-shared key. For group, we're going to use Diffie-Hellman group 2. Like I said, lifetime, we're going to leave it as default. Then the encryption, we're going to use 3DES. Okay, so that's it for the first part of your phase 1. Now the next thing that we need to configure would be the pre-shared key itself. So crypto ICCamp key, and we're going to use Dylan is amazing as our key. Then address, we are going to use this against what WAN IP. What's the WAN IP of the other end? So it's going to be 103.40.40.2, and that's your phase 1. Next, we need to create your phase 2, and you do that by typing crypto IPSec transform set, and you give it a name. We'll name it transform, and in this one we'll use ESP32 and ESP MD5 HMAC for our encryption and our hashing. Next, so that's your phase 1, that's your phase 2. Now we put them, this is where we put them together on a crypto map. So crypto map, I will call our crypto map. Then we give it the number, then IPSec ICCamp. It will give you a note, yeah, because before that thing, it's basically letting us know. It's just like an access list. Access lists are so powerful, but the thing with the access list, not until you apply it, then it's pretty much useless. Okay, so next we need to set the peer. So the peer would be the WAN IP of the other end, which in this case is 103.40.40.2. We need to set the IPSec phase 2, which is what we configured here, and we named it transform. And we need to set so basically this is the tunnel, this is the peer, this is the IPSec, this is the IPSec configuration or attributes that you will be using. And now what would be the prefix? What's the allowable LAN ranges that we're allowing to talk to each other? So I'm just gonna set IP access group, then we're gonna name it ACL VPN. Okay. Oh, what? I think I made a mistake on my config here. Oh, sorry, it's not set, it's match. Sorry about that. Match address. Then we're gonna name our ACL VPN. So basically, we set the show run section crypto map. So basically, this crypto map is telling us, okay, so with the peer of the other end, use this IPSec config. Then this is what we're going to allow. These are the subnets that we're gonna allow to talk to each other. Now we still haven't written this ACL, so obviously this is an extended name ACL. So let's write that now. Okay, so we do IP access list extended ACL VPN. We are going to permit our own LAN range, and we are going to permit it to talk to the LAN range of the other end, and that's it. technically that's it. That's if we're just talking about IPsec VPN site to site. That's all there is to it. And the last bit would be if we go to our WAN interface, Fast Ethernet 1/0, we're gonna start applying our crypto map. And the name of our crypto map is map again. Technically, as far as site-to-site VPN configuration is concerned, that is pretty much it. But wait, there's more. We still need to exclude this range from being netted. So remember, we are using path in order for our LAN range to reach the internet, right? So how do we exclude our LAN traffic from being netted to reach the other end? So the first thing that we need to do is we need to set up another access list. We'll call that nonet. ACL nonet. Then we are going to deny our LAN range source to the destination of the prefix of the other end, while at the same time any traffic from our LAN range we're going to permit it to any destination. Okay, so that's the ACL. Next, we need to create a route map. So let's say a route map rm no net, and we'll match IP address ACL no net, and that's it. If I look for that config for IP net, which is this guy right here, so we're gonna do another netting IP net inside source route map, and we're gonna call in our route map, which is rm no net. Okay, then the interface would be the WAN interface, and we do an overload, and that's it. So if we so let me just copy everything that we have configured so far. Let me open my notepad. Okay, so that's map, and we did this as well. Oh, by the way, we need to erase this one. No. Okay, and we're just gonna leave this here. Okay, then we need the ACL, this ACL, and the ACL VPN as well. Oh, and this one. Okay, so pretty much this is what we've applied. Okay, so let's quickly go through it. Ooh. So pretty much we wrote phase 1. Okay, we use 3D as the encryption, MD5 as the hashing algorithm. We're gonna use a shared password as far as our authentication. We're using Diffie-Hellman Group 2. Then on the pre-shared, we use Dylan as amazing as the password, and this is what we're going to use for our peering with this WAN IP. Then the next step would be to our phase 2, and we called it transformed, and we use ESP3 for our encryption and MD5 HMAC for our hashing. Then we put them all together on a crypto map, and we called the crypto map, wherein we set the peer, which is the WAN IP of the other end. We called in the transform set, which is this guy, and we match it with a VPN, with a ACL called ACL VPN. So basically we're saying to only call this ACL to only allow our subnet to talk to this certain subnet, which is this guy right here, where we are only allowing our LAN subnet to talk to that destination, which is the LAN side of the other end. Okay, next, so this crypto map right here, we apply to our WAN interface. So we go to our WAN and we type in crypto space map, then map. Okay, now then we create a path wherein we are excluding, oh, you know what, I forgot to include the route map. Where's our route map? Route map. Oh, there you go, our route map. Okay, so we have a route map wherein first we created an ACL, another extended ACL called ACL NoNet, wherein we are going to deny our traffic from the LAN subnet traffic, but permit any traffic from our LAN subnet to reach any destination. So the reason we have this is to exclude it from being natted as it goes out the WAN. Okay, so that's why we have this route map here. We called it RM NoNet, and we match it to the ACL. Oh, something's wrong here. Match IP address ACL NoNet. Oh, okay. Okay, I need to create that. I need to correct that then. Just give me a second as I correct this one. Copy, paste. Remove this one first. Copy. Yeah, so this is saying that match it with those two ACLs. What have I done? Okay, copy that, paste, and there you go. Show run start RM no net. Okay, cool. So there's my route map. Okay, so let's remove that from there. And that's it, pretty much. That's it for the Brisbane office. Now, all we need to do now is pretty much create a mirror config of this one. Copy. And we'll put it right here. Okay, so like I said, phase 1 and phase 2 should match. So we're gonna keep this phase 1. We're gonna use the same pre-shared key, and this one, this will be the WAN IP of the Brisbane router, 80.1. Then we use the same thing. Paste. Oh, silly me. Sorry, it's really early in the morning. Then we paste that there. Then, am I using the same WAN interface? No, it's 00. So my WAN interface here is 00. No NAT. 0. So we're gonna use the opposite now. 2, 2, then 1. Okay, so I guess that's it. Now let's go to the Gold Coast router. Why did this? Okay, anyway, can't be bothered. Okay, so let's ping the other end, which is 203.149.80.1. Yes, I do have reachability. Let's ping the any LAN subnet on the other end. It's unreachable. Cool. And yeah, let's start pasting this config, shall we? Okay, copy that. And there you go. By the way, show run. Before I do anything, let me just ping from the PC 10.1 200.1.1. I guess so it's still unreachable. That's fine. Show run pipe include show run pipe include IPNet. Oh, pipe include IPNet. We need to remove this guy. No. Dynamic mapping. Continues cannot remove. What do you mean? What's that? Okay, let's still work around. No IPNet outside. Okay, and we apply this again. No IPNet. Then overload and go back to 00 IPNet outside. And okay. So if I show run, let's have a look. So we have our own policy, and this time we're pointing to 203.149.80.1. We're using our transform set. Our peering is the other VPN. Then we put our crypto map on the WAN IP. We have our no NAT policy here, which points to our route map, RM no NAT. RM no NAT, which RM no NAT here, which calls the ACL no NAT, which is this guy, which is telling us to do not NAT any traffic from our LAN subnet to this LAN subnet. And what else? ACL VPN is also here. Okay, so let's Let's initiate some traffic. Oh, there you go. So let's try to ping the PC on the other end. Okay, so now we have communication, and I'm pretty sure if we go to the Brisbane router, if we start pinging the default gateway of the Gold Coast router on the LAN side, it's gonna start communicating, and also the PC, and there you go. Okay, so some commands that you may find useful. So show ICCamp, show crypto ICCamp SA. So this is going to show you your phase 1 verification. Basically, this is your phase 1 verification command, wherein your destination, you receive traffic from this destination, which is the WAN IP of the Gold Coast router. So if we move this to here, so the destination is 203.149.80.1, which is, oh wait, isn't that us? Yeah. So for our WAN IP, source it from the other IP, which is this guy right here. QM idle would let you know that it's actually working. Okay. If another command that's useful for you would be IPSec SA, you would be after this information here. Okay, so if you have your encap decap information, if this is going up whenever you try to send any traffic, like a ping, so let's say let's send another ping, and if we run that command again, you will notice that this has increased again. Okay, so you just sent 5 packets, and you notice that these guys increased by 5. So same goes with the other router here. If we do show crypto ICCamp SA, so this is going to verify. I think if this will show no NM state from memory. If you're seeing that, it means that there's something wrong with the link. Then you need to do your debugs. By the way, in terms of debug, you can do debug crypto ICCamp and debug crypto IPSec. So whenever we would send some interesting traffic, and that's alright, right. It's not triggering anything. That's odd. Maybe because it's GNS3. But anyway, it should be triggering like your debugs as it sends out traffic across the router. Okay. Basically, that's it. That's your basic site-to-site VPN. I hope this has been informative to you guys. If you have any questions, just let me know. Again, this is Dylan, and I hope you have a good day, guys, and see you again on the next video.